Hello and welcome. This is a Edexcel A2, obviously C4, January 2012 question 3A. So this question is quite a nice one. It's a binomial expansion one. It's actually, I don't personally think it could easily be in a C2 exams question, so it's quite a nice one they've thrown in there. So basically we're told to expand this. It's 1 over 2 take 5x squared. Now you should spot, so yeah, this is question 2, just put 2 there. So there's a couple of things that you need to spot straight away. Hopefully you will have done it. I was going to say, some people, I was reading the exam report, some people try to do you've got to look at the word expand. Some people might attempt to differentiate, which is completely wrong. So it says expand. There's no way of expanding this on its own, so we have to convert it into some other format. Okay, so the first thing you should have done is recognise anything on the bottom. If it's squared on the bottom, it becomes -2. If it's cubed on the bottom, it becomes power of -3. So rewrite this. You can either do it as 1 times 2 take 5x squared, or because it's just 1 over, I'm just going to do 2 take 5x to the power of -2. However, we can't expand this. Well, you could say, but we've got the expansion where we've got ax plus b to the power n, and we have another binomial expansion for that, which we can't use that because you never use it in C4. But more to the point, you can't use the normal expansion we'd use in C2 because it's got a negative power. So the only other one we have, the only other expansion we have is where you have 1 plus ax to the power n. So that's 1 is equal to 1 plus an plus the n take n, n take 1 over the factorial of 2 times a squared, and it goes on. But this is not in the form of 1 plus ax to the power n. Okay, first of all, it doesn't matter that it's a negative. It's because this isn't a 1 in front. So what do? Well, this leads me on to a key thing that this is the key bit of information in part A. Well, it says it's up to the power of x squared, but really that's just means doing it up to x squared. You don't need to go any further, obvious. So what we do, this is the key bit of part A. So you put part A there. Because we want it in the form 1 plus ax to the power n, we have to divide all of it by 2, because we've got 2 then, we want that to be 1. So therefore we take 2 outside the brackets. However, because everything inside these brackets is the power of -2, anything we take out as a common factor, there's another way of dividing it, has to be to the power of -2. So a key thing to do would be write 2 to the power of -2, and then 1, take 5, and then you can either write 5x over 2 or 5 over 2x. I'm going to write 5x over 2, so the power of -2. So therefore you could simplify this even more, so there's 2 ways you could either write this now. Personally I prefer to write it as a quarter times 1 take 5x over 2 to the power of -2, all of it to the power of -2, and you could expand on that. The reason I'd write it like that and not as 1 take 5x to the power of -2 over -2 is you might be tempted to put that back over in the original way. You might be tempted to say, well, that's 4 over 1 take 5x to the power of -2, which is the same as saying this, but you're going to be getting that circle making a mess. So I'd leave it in that kind of form. Okay, so if you remember, our expansion, as you say, you're given this in the exam. So it's 1 plus ax to the power n is equal to 1 plus an, etc., and it will go on in a normal vein. But because we've got equality here, we don't include this. We expand this as we normally would, with ignoring the power in front, so the coefficient in front of it. And then we times the answer by a quarter. So what I'm going to do is I'm just going to expand. As I said, you can do this in numerous ways, but just the way I prefer to do this. First thing I do is, okay, it's in this form now. This form is exactly the same as this over here. So I write down what a is, what n is, because we don't have b, as we're only considering this form. So a. Now a is quite confusing because it's not just -5 over 2. It's -5 over 2 5x over 2. And that obviously becomes apparent when you have 1 plus an, and you come with this as an expansion with no x's in it, which couldn't possibly be the case. Okay, so write a is that, and then n to the power minus 2, just write n is equal to minus 2. And you can either underline that whatever you want. And then I put it again in this bubble. So 1 take 5x over 2 to the power of minus 2, and follow the expansion as normal. So that's 1 plus a times n, obviously a being minus 5x over 2 times, or you could just put another set of brackets, minus 2, and obviously that's going to cancel out. But I wouldn't work it out just yet, I'd carry on with your normal expansion. And then it's n times, and you only need to do another section now. So it's n, which is minus 2, times minus 2 take 1, which is minus 3, over the factorial of 2, which is 2 times 1. Obviously that's going to be minus 3, but I wouldn't cancel that out just yet. Times a squared. Now remember, it's not just minus 5x squared, it's minus 5 over 2x, and that's all squared. So I'm just going to write minus 5x over 2 all squared. I'm not going to calculate anything just yet to keep it nice and simple, because I am quite simple. So anyway, simplify this down. Now we can, so therefore the 2 and 2 cancel out, the minus and the minus cancel out, so we just add 5x. And then we'll work this out in stages, put it in a little, obviously you don't have to, you could just write the answer down, but obviously that's going to be minus 3. No, sorry, it's going to be plus 3, because minus 2 times 3 is obviously 3. Oh my god, that's so embarrassing. 6. Oh god. And it cancels down to 3, so obviously I'm jumping ahead of myself there. And that's 3 times, no it's not times minus 5x and all squared, so it's 25x squared over 2. So that's equal to 75x squared over 2. Or you could have done it another way, but you would have simplified it to that. Okay, so let me just, I'm going to make sure I've actually expanded that right before I've go and say, oh, that's the answer. So as I said, you know, you can't have the marks in next to you, but I'm just purposely just trying to help you. There you go, 75x squared. Oh, made a mistake there. It's actually over 4. So I did that on purpose, obviously, to check if you were awake. So plus 75x squared over 4. I even said you have to square both top and bottom, but I didn't. So anyway, that's the answer to part A. So I'm just going to sort of pause it a second, so that I can get rid of all this without you having to see my head. What you still do, but you never mind. Anyway, so just give you a second to copy that down, and then I'll read that to part A, and then we'll continue with part B, etc. So there's just a bit on that we haven't actually finished. We still got to times it all by a quarter. So 1 times a quarter is a quarter. 5x times a quarter is 5x over 4. And 75x squared times a quarter is plus 75x squared over 16. Okay, so that's the end answer to part A. Okay, so as you can tell, it's basically it's quite a simple binomial expansion. It's quite a nice one, really. So it's nothing too strenuous. So thanks for watching, and we'll see you in part B. Okay, so this is part B for January 2012, question 3B. Okay, so what we're going to do now in this part is we're asked to expand, so it's 2 plus that would have looked at this, 2 plus kx over 2 take 5x all squared on the bottom, and we're told that is equal to a half plus 7 over 4x, 7x over 4, sorry, plus ax squared. And in the first part we're asked to work out what k is. Now the first thing you're meant to realise is that this is 1 over 2 take 5x all squared, and this is 2 plus kx over 2 take 5x all squared. So therefore we said that this was the same as 1 times 2 take 5x to the power of minus 2. So therefore, using the same idea, this is going to be 2 plus kx times 2 take 5x to the minus 2 minus squared. Okay? So, as we know what 2 take 5x to the minus 2, we expanded that, that's the answer we got up here. Therefore we can just input that into this expansion. I mean, we could expand it here again, but it'd be completely pointless. We'd end up with the same answer, or we should. So therefore it'd be 2 plus kx times a quarter plus 5x over 4 plus 75x squared over 16. Okay? So if we expand this out, I'm going to expand the 2 first. So then it's going to be equal to 2 times a quarter, which is a half, as we told up here, plus that's going to be 5x over 2 plus 75x squared over 8. Okay, so then you do expand the k part of that as well. So you do kx times a quarter, so that'd be plus kx over 4, or a quarter of kx, plus 5k squared over 4, kx squared, sorry, over 4. And then you could do this, but it'd be pretty pointless, because we're only asked to work out k and a are, so we don't really need to do it up to x squared in this, but we put it in anyway. Plus 75k x cubed on 16. Okay, so what you'd do then is you'd group it together, so you'd simplify this down. Now you've got the expansion, so obviously the half is going to remain on its own. Group together the x's, so look at all single x's. So you've got 5x over 2, kx over 4, there you two on, so it'd be plus 5 over 2 plus k on 4, that's all times by x, plus, so you get to the x squared, so it would be 75 over 8x squared plus 5k on 4x squared, so that would be 5k on 4x squared plus 75 over 8, and it's all times by x squared. And you could leave that out now because we're not really interested in the x cubed. I mean, you could write it in, but I can't be bothered. So we know from using this answer that whatever, so this is saying 7 over 4 times x. What we've got here is 5 over 2 plus k over 4 times x. So therefore we can say, because this is the expansion of that, we can say 5 over 2 plus k on 4. So please say I've done that right. Yeah, so 5 on 2 plus k on 4 is equal to 7 on 4. So if we times all of it by 4, therefore we get 10 plus k is equal to 7. So therefore we arrange this to get k is equal to minus 3. Okay, so that's part B over and done with. So we don't need to do any more with this simplifying now, we just need to work out what a is. Now we know a is the coefficient of the x cubed. X squared. So therefore, as we know what k is, we can put it into this equation. So therefore, 5 times minus 3 on 4, because this is using this part of the x squared, plus 75 on 8. And because that's x squared, the coefficient of x squared, and we've got the coefficient of x squared is a, therefore this is equal to a. So 5 times minus 3, that's be a genius to work that one out, it's minus 15 on 4, plus 75 on 8, and as you've got a calculator in C3, you just whack that into a calculator, and you should get 45 on 8. So your answer to A. I wouldn't simplify that, because I always leave it in exact form or non-decimal form. Put that A is equal to A. Okay. So that'd be your answer for C. So question 3 is quite a nice one, I think, although I've made quite a few mistakes. A key thing to watch out for is remember you times the expansion of that by a quarter, because you have to take out 2 as a common factor. Remember the power comes with the 2. Key thing to put in part B is this is the same expansion as you did in part A, but you've got this 2 plus kx in the top instead of 1, and therefore you times the expansion that we did for part A by 2 plus kx. To find B, you group them together. So you group together the x's, you group together the normal one, non-x's, the x's, the x squareds and the x cubed. I would leave the x cubed actually because you don't really need to know that, but it's good to put it in your expansion because you're showing you have expanded all of it. And then we know 7 over 4 is equal to b, and 7 over 4 is equal to the coefficient of x. So therefore you make them equal to each other in the expansion you found out, work out what k is, put k back into the equation to find out what the coefficient of x squared is, and that gives you a. That's for part C. So thanks for watching. Hopefully it hasn't been too much of a chore. Sorry about making a little bit of a mess and having to put 3 in 2 different videos. So thanks for watching, and hopefully we'll see you in the next part of this video.